Hello, I wanted to do a series of videos on the solar system. Let me share my screen. I'm going to talk about a few things dealing with the origin of the solar system and from a Christian perspective, but really I'm only going to bring in this one verse you see here at the very title page, "The heavens are telling the glory of God." It's Psalm 19:1. The rest of this is mostly an explanation about how some things work in the solar system, and it's going to have four parts. This is part one. I'm going to talk about orbits. Part two will be about moons and some related things. Part three will be tidal forces, and part four will be magnetic fields. In this presentation, I am not going to prove that God created the solar system. Prove is not a good word. And since this isn't a sermon or a Bible study, I'm going to try to speak with some reserve about some of these topics. Scientists who've discussed items about how the solar system works, if you go back in some time, their record of being accurate has not been really good. And so I'm going to try to speak with some reservation and not too much authority about how some of these things work. That'll affect mostly the other topics, the other videos. This one, I think, will be pretty clear about most things. I want to provide an understanding of some aspects of the solar system that point to a created origin for the solar system rather than a naturalistic origin. So if we're going to talk about orbits, I think one of the best places to begin is on the golf course. This is Augusta National Golf Course in Georgia, where they play the Masters Golf Tournament. This is the famous hole number 12, a 155-yard par 3. And the golfer here has just hit the ball off the tee, and you might can see it right there, almost in the center of the page, and the ball is headed toward the green across the water there. Now, what people really probably don't normally think of, as a matter of fact, they never think of it, is that the golf ball that the golfer just hit, that golf ball is now in orbit. Now you think, how could the golf ball be in orbit? Well, it's actually in orbit and would orbit around the center of the Earth, except for two factors. Really, just one factor, and it's friction. First of all, the ball is going to run into the air, and the air resistance will tend to slow it down. It'll mostly slow its forward progress. So it'll trace a path sort of like this, and the arrow pointing backwards away from the way he hit it is the air resistance that will slow the ball up. But then the more significant thing is that as gravity starts to pull the ball down, it will have a more significant friction, and then it will hit the surface of the Earth. And when it hits the surface of the Earth, hopefully on the green, there it will stop. So friction will prevent the ball from going into orbit. But what would happen if this was some sort of a magic ball that didn't run into any friction at all? No friction with the air and no friction even with the surface of the Earth. In other words, it could just pass through the surface. What would happen when you hit it? Well, what would happen is it would look something like this. The golf ball would trace out a path around the center of the Earth. Now, that path would start at the golf tee. It would go up in the air. It would come down at the golfing green, and then it would proceed on through the Earth, around the center of the Earth, and out the other side, where it would pop up in the air a little bit, and then come back around the center of the Earth and go back to where it started from, at the golf tee. That is what would happen if gravity was the only factor acting on this ball after it was hit, if there was no friction. Now, what if the golfer had superpowers? If he could hit the ball so hard that it would go way, way up in the air, even higher than the International Space Station. So I've drawn the picture again. In this case, the golfer hit the ball several hundred miles high, higher than the space station flies. Once again, this is our magic golf ball that doesn't have any friction, so it goes through the surface of the earth. But this ball would go up in the air, and then once again, it would come down and hit, pass through the surface of the earth, and then come back around and end up where the golf tee started. So the ball just goes in an elliptical orbit around the center of the earth. It's an elliptic orbit that intersects the surface of the earth. Now, what would happen if the golfer had so great a superpower that he could hit the ball so hard that it traveled at 7 miles per second? Then what would happen is the golf ball would take off, and at 7 miles per second, it's reached what's called escape velocity. It's going fast enough that it can escape the gravity of the planet and sail off into outer space, or really just become some other object flying around through the solar system. This would be called really a hyperbolic orbit. It escapes Earth's gravity. So, what does all this mean? Well, the message is there's no way to hit a ball and put it into orbit around the Earth. It either returns and hits the surface of the Earth, or if it's hit hard enough, it escapes into the outer space. So that's just a golf ball, but it's true of any object on the surface. You can't start from the surface of the Earth and put something into orbit around the Earth. With a two-body system like the Earth and the Moon, there's no way something can start from the ground and end up in orbit around the other body. So how does it happen with spacecraft? Well, what spacecrafts do is, in short, they steer. Here's a picture of the rocket and it lifts off, but all the energy doesn't happen right at liftoff. It continues to burn. We put the satellite in orbit by doing what, at least in some spacecrafts, they call an orbital insertion burn. Once it gets up fairly high, they point it not straight up, but kind of along the direction of the Earth, and they continue to burn until it's in orbit. Really, the spacecraft is steered into orbit. That's not something that can happen naturally. It's designed that way. So now let's talk about gravitational capture. Can an object flying past the planet be captured and become a moon? I think most people know that from time to time, meteorites strike the surface of the Earth. Sometimes they're fairly big. Sometimes people have speculated that in the past, maybe a very large asteroid might have hit the surface of the Earth. So things are always flying in our direction. Sometimes they hit us, but can any of those things actually like get captured and begin circling around the Earth like a moon? And the answer is no. This is actually not possible in a two-body system. It is possible if there's a third force at work, but if there's just two things, the planet and the potential moon, and you're dealing with the gravity of both, it is not possible to do this. The object flying past will enter a hyperbolic orbit and escape the Earth's atmosphere. It may trace any of those figures there. We've got a blue, red, green, and yellow line. And depending on how close it comes to the Earth and how fast it's moving relative to the Earth, it may curve different degrees of a curve, but it'll always end up leaving the Earth's gravity with just as much energy as it had going in. It'll never be captured and become a moon. The reason that I'm doing this, the thing that triggered me doing this presentation was when a friend, Joshua Jensen, asked me if I'd seen this article about Earth gaining a new moon. And I remember thinking, actually, that can't happen. So I read the article, and it did talk about Earth having a temporary mini moon. But what really happens with this is it's an object, which is an asteroid, which is approaching us very slowly, coming sort of from the same direction that we're already going. And so it will get pretty close to the Earth and it will stay with us and circle partway around, and then it's going to leave. It's going to look something like that yellow line. So even this Earth mini moon isn't really a moon. It's not going to make a full journey around the Earth even once. It'll enter Earth's gravity and leave. So the message here is, in a two-body system, an object cannot leave a planet and become a moon orbiting the planet. An object cannot fly past the planet and be captured to become a moon orbiting the planet. Hmm. There are more than 200 moons in the solar system. And there you see, I just pulled up a picture of the four Galilean moons. Those are the really big moons that circle around Jupiter that Galileo saw as soon as he built a telescope. So, how could we have moons if we don't seem to have a good way to cause anything to ever become a moon? Well, one way is to say that God just created them just like that. Are there any exceptions to this comment, though, about a two body system? The answer is that there are no exceptions. Uh, these rules are determined by the laws of physics, and it doesn't matter if you have billions of years or just a few years, you're still not going to create a moon with a two body system. Now, the leading naturalistic origin theory of Earth's moon is that something big collided with the Earth and broke part of it off, sending fragments into orbit, something like in this uh, picture here. And the fragments eventually coalesced into a moon. I'm hopeful that this presentation has already given you an idea of how unlikely that would actually be to work. It's kind of a hand waving explanation of how something like this would happen. But maybe we should look more closely at, I keep saying two body system. That's kind of a caveat I've set on all these things. So I probably needed to explain that a little bit better. There are actually more than two forces at work. The two body system caveat implies that there are only two forces at work, the planet's gravity and the potential moon's gravity. But really, there are more. The third force is gravity from the sun, and it is always there. Now, it's rarely going to make a difference in capturing anything and putting anything into orbit. The sun's gravity will tend to pull the same way whether you're entering or leaving the approaching planet, and so it's rarely going to make a difference. Rarely not meaning exactly the same thing as never. Another thing that could happen is that you could have two items that are already orbiting each other. And as they approach a large planet, in ideal conditions, they could kind of do a dipsy doodle approaching a planet with one of those items escaping and one getting captured. Or you might have one crashing and the other getting captured. In that case, the two items would provide an additional force not accounted for. You might can imagine that that's a little bit hard to see how that would happen too, but in theory, it's possible. And I can tell you, it's the going theory for how one of the moons, at least in the solar system, developed. I'll talk about that next time. That will be Triton, one of the moons of Neptune. You could have off gassing of the potential moon. In ideal conditions, that would act like its thrust if the moon was gassing, and the thrust could apply a brake to help it get into orbit. You could have uneven application of friction that could theoretically catch something in orbit, like if there was something slowing it down, maybe something was colliding with as it was coming into orbit, something like that. Or you could have gravity from some other external body, like a giant planet passing through the solar system and pulling things in a certain direction. In general, a naturalistic idea about much of the evolution of the solar system is you had a primordial spinning cloud of matter and gas. And for the planets, they would say that some of the planets and some of their primary moons evolved together from a spinning gas and matter cloud. A natural origin of orbits in the solar system has to postulate one or more of these conditions early in the solar system's history to get to the solar system as we know it today. Now, I can't really tell you what to think about each one of these possible additional forces. But if I could get you to glance down at those and think about just what we've talked about in the presentation so far, you can make your own determination of if you think that any of those are really very plausible. It's kind of a matter of, can you imagine this happening? Um, and I'm not answering it. I will let you say what you want to say about that. So in conclusion, this presentation is kind of a foundation for the three others that follow. I'm going to talk more in detail about moons in the next one, and then some other things after that. The conditions and forces currently at work in the solar system cannot explain the orbits in the solar system. In other words, you can't start from something else and get to our current orbits. You have to have introduce some other special force. It doesn't look like the solar system could have created itself. We are only on the very, very beginning of this study, but initially, I think you can say that from the beginning, it looks like the solar system is more like a created solar system than something that could have just come into being by chance. This is the first of a four-part series. I hope you can watch the others. The next series, which should be out shortly, will be on the topic of moons.